Is this thing on? Could be. Oh, I think we are. I think we are. Yay, we're on. Okay, are we on? I hope so. All right. The stream is continuing. Okay. This is weird. Oh, yay. All right. Hello, folks. Yeah, still getting used to this whole live stream stuff. So, okay. What I wanted to talk to you guys about today was, let me see if I'm going to be able to see this here at all. Yeah, okay, so I know I don't have the greatest camera setup ever, but hey, that's me. What we've got here on the bench, and something I've been working on today, is the Innova inverter, and it drove me a little bit crazy, and I figured I might as well share some of that with you guys. So this thing has been a project that I've had on the back burner now for some time, and I really just wanted to get to grips with it, and that's what I got doing today here. But it's, according to the PCB anyway, it's from a 2002 vintage, and this is a particularly crappy system, and I say that now that I've seen quite a few inverters. Now, that being said, it busted my nuts today trying to figure this thing out. So, all right. Little bit of background for us in that. Why am I actually doing this? Well, what I've wanted to do has been to develop a logic board to drive it, and I did develop one that basically ran the IGBTs directly. But what I wanted to do was to make something that would run the Innova driver board itself. You know, be able to reuse that thing and kind of get, you know, the most out of it. So that's what I've been doing. Yeah. So we got at this thing today, and I have pretty much got it worked out, but I'm just going to tell you guys what this thing does, because it's just beyond weird. So maybe, you know, some of you will find it less weird, or not, possibly. So we've got this logic board here. So I've got this powered up. It's basically just running as a power supply at the minute. We have our 3 IGBT drivers, but rather than have a, you know, rather a traditional system on there, like you know, where you have your 6 drivers and you have your 6 channels, and you've got some fault lines, and you know, you've got some enable lines and power lines and all that kind of thing. This damn thing practically hardware generates the PWM. Now, what do I mean by that? Well, the microprocessor here, all as it does is it generates a 10 kilohertz square wave, and that is fed into some comparators and op amps here, and this whole affair on the driver board itself basically lets a 0 to 5 volt signal, also generated by the microcontroller, vary the PWM mark to space ratio and put power into the motor. So this is probably the crudest system that I've seen for controlling an AC induction motor ever. So yeah, I would not, I know there's a lot of people have these, but I would certainly not be trying to use this existing control system if I were you. So when am I going to be able to supercharge? Well, that's an interesting question. I was going to be going to the car today, but we got about 1 millimeter of snow last night, so the whole country just ground to a complete halt. But I hope to get down there tomorrow, and if I do, one of the jobs I'm going to be doing is fitting the Tesla charging port. So once we get that fitted and we get the charger and the high voltage junction box and all that stuff fitted, then we're getting closer to supercharging. So not sure when, but it will be definitely on the cards. So yeah, that's this thing, guys. This is what I was doing today as I was snowed in. And but at least we'll be able to reuse some of it. I'll be able to run, PWM channels in here to the discrete driver stages, so that shouldn't be too bad. We'll be able to reuse the current sensors and all the things that I kind of wanted to do, but I had just never seen a control system as crude as this, and I would certainly shudder to think of trying to drive a car with this thing. I wouldn't think it'd be much fun. So, other job that I had going on during the socked in period. I'll try and pan you guys over here a bit, but there's a bit of a lag in the video here, so I'm not going to be able to see it too soon. Is the Bmw i3 Inverter. Oh, I don't think we've panned enough of the way. Hang on. My live streaming skills are as bad as my video making skills, that's for sure. Okay, here we go. There you can see it. Hopefully you can see it. This guy. This is the Bmw i3 Inverter and, power module and various other gubbins in there. Now let's get you guys in a bit and be able to see it. What you've got here is a very nice power stage. There's a film capacitor in here, a complete 6-pack 800 amp 600 volt IGBT module, and a driver board. All that's packed in here, and yeah, I've been able to work out what most of the controls do for this thing, and we're going to be using this for a project coming up soon. The original logic board was a real ball of wax. Let me see if I can find it here. Look at this thing. I mean, there's enough, processing power on this and enough components on this. I could probably make a fortune mining cryptocurrency if I reprogram this thing. So yeah, we're not going to be using that. That's junk. I'm certainly starting to accrue a large portion of logic boards that we don't need anymore. So yeah, Bmw i3 inverter, and there's also a DC-DC converter, and there's a smaller inverter in there as well for running the the air conditioning pump. So that we need to work on a bit more, but just wanted to show you guys kind of what we've been doing here. And so this and the crappy Innova have been kind of where we've been at now the last few days. So anything else on your mind, sports fans? And Do I have any idea where we could get an American supercharger cable? Short of visiting a supercharging station at night with a pair of bolt cutters, no. So that is something that I'm also going to have to look at, because one upcoming project that I'm going to be announcing fairly soon is going to be an open source supercharger. So that is going to need some kind of a plug to connect it on the supercharger side. Other sockets and plugs and stuff for CHAdeMO and CCS are all readily available out of China. So I guess you're going to have to do some kind of 3D printing or something like that to work out a plug. So, all right. So one other question that I have been asked recently, and I figure I might as well answer it now on this live stream, is about pre-charging. Now, I might make another video about this, but I've had about 4 or 5 people now recently ask me about pre-charging and what is pre-charging and why do I need to pre-charge, and can't I just avoid that? So I figure, seeing as we have the i3 inverter here, I will give you guys a very quick briefing as to what that is and why we would need to do it. So, all right, let's get back over to the i3 inverter. Now, you'll note that I mentioned, or remember that I mentioned, or I might even remember that I mentioned and not sound like a complete moron, that there's a capacitor here. Now this is, not, I suppose, the kind of capacitor that you might recognize. You might recognize the larger electrolytic caps, but basically all motor controllers, be they inverters like this one for driving an AC motor or a DC motor controller, will have some kind of a large capacitor bank in them. Now, you typically don't want to leave that capacitor bank charged up all the time because it's kind of dangerous. So usually in these designs somewhere there's what's called a bleeder resistor, which basically bleeds the voltage down off the capacitor bank, so that at all times, the capacitor is at 0 volts. Now, you typically, in most EVs these days, the high voltage systems run anything from 200 to 400 volts, usually about 350, 360 volts. So you need to connect your battery to these terminals, or some connection to your controller or inverter in order to run the thing, to put the DC power in here so that you get your AC power back out. Now, to do that, you've got this capacitor that's basically sitting at 0 volts, and a discharged capacitor looks very much like a short circuit to anything that you're going to connect to it. So if you simply come along with your big contactor and you just close the contacts and you apply a 360 volt battery to this with the capacitor discharged, something's going to go bang big time. Typically it will be either your capacitor or the contacts in your contactor and stuff like that. So typically what you do is you have what's called a pre-charging circuit. And the pre-charging circuit is typically just a relay and a resistor that lets you slowly charge the capacitor bank up to the battery voltage, so that when you then close the contactors here, there's very little, if any, voltage difference between the capacitor bank and your battery voltage. So as I say, I might do a video on that and do some demonstrations and stuff, but just wanted to clear that up because it's kind of a fundamental thing in EVs. So yeah, as I said, I've had almost a half a dozen queries on that over the last week or two, so figured might as well throw that in there, and we'll yeah, we'll kind of, you know, see what you guys think of that, and perfectly happy to kind of fill in the blanks there. So what do we got? After from European supercharger to CCS. Well, no, what I meant was that there are, you can get the plugs for the CCS, and you can get the plugs for Type 2, and you can get plugs for CHAdeMO now very easily from you know, the sites like AliExpress and, you know, some of the other Chinese retail type sites. But the Tesla supercharger plug would be a much different beast. I doubt we'd be able to get that off the shelf anywhere anytime soon. But stay tuned, and we'll see how we beat that particular problem once we get to it. How much kilowatt hour battery will there be? I assume you're meaning in the Panzer. We will have either 55 or 60 kilowatt hours of battery in that car, because we're looking to go a solid 200 miles. So there'll either be 10 or 11 Tesla battery modules in there. So that is the plan for the Panzer. So yeah, that's kind of me, guys. I just don't even know why I'm doing this, but why the hell not? Figured I owed you guys a live stream anyway. I suppose I should have better advertised it, but when I was working on this piece of ANOVA crap today, I just said to myself, you know what, I need to go tell the internet about this. So there you go. Well, great. Anyway, that lubricated me. The enjoyable thing about this is I get to see myself on the screen here about 10-second delay, so I get to watch myself make an idiot out of myself without any chance to do something about it. So, alright. Yeah, so the plan for this thing is to make a logic board for it, but it'll be a bit of hacking on the PCB. Sadly, it's not going to be a plug and play job. The i3 inverter, the biggest problem I'm going to have with that, believe it or not, are the connectors, because they use this ridiculous kind of a, let me see if I can pull one off here for you. I use these kind of ridiculous little mini IDC plugs, and they're made by some company that's just, you know, they're just pure unobtainium. So I'm going to have to figure something out, figure some way around this, because otherwise it just gets messy. So that we are going to have to deal with. Oh, in other news, we will have a supply of logic boards soon. So we will have charger logic boards for you. These guys will be available soon. They will be professionally built and tested, and hopefully we'll have some software for running the charger soon, and we will also have drive unit logic boards for you. So both for the large and the small drive units, we'll have these boards available soon. And yeah, because we've had a good few iterations with them, and you know, kind of working out bugs and so on. So that's going to be happening. Will the board show up in the EV BMW shop? Yes, I will have a web shop at some point. Probably be, probably within the next couple of months anyway. Do I plan to add a CHAdeMO port to the Panzer? No, because if I want to CHAdeMO charge the Panzer, I am going to get myself one of those Tesla CHAdeMO adapters, and we're going to hopefully use that guy. So okay, what else we got going on here? Can I explain a little about the web interface on the Raspberry Pi? Certainly. Yeah, that's something that I kind of, you know, collectively came up with, was that the main problem that we had with the inverter. Now, I kind of say it in terms of the Tesla. You know, I say it in terms of the Tesla board, but it also, you know, in terms of the traditional Hubner inverter, there's a very nice web interface that basically lets you do all the configuration and plotting graphs and, you know, all the kind of human interface side of it that you would like to do. Now, problem with that is that it is a server-side application. So what that means is that you need to install a web server on your computer and then connect that with a serial to USB cable to talk to your inverter board. You know, that's either, as I say, be it the Tesla version or be it the, you know, standard version. Now, that is challenging, to say the very least. I've done it a few times, but it is, you know, it is not easy to do. So what I did was I might have one lying around here actually. Let me see if I can grab one of these little Raspberry Pi boards. I'm a cheapskate, so I don't have a wireless microphone. So I've got a wired microphone. So good news is it's quite a long wire. So what I did was I got myself some Raspberry Pi 0W boards. Now they've kind of a handy feature in that they are quite small, they are quite cheap, they have a single kind of it's a system on chip kind of a processor, and these guys basically let you run Linux on them, and you can run a web server on it. And so what I did was I made a SD card image that you can put on a SD card. You can connect this then to your inverter. All you got to do is give it 5 volts power, and what it does is it creates a wireless access point, and you can connect to that then with basically any you can connect to that with any wireless device, like a, you know, phone, laptop, tablet, etc. And there's no need to install any software on your computer. There's no need to do anything. It's literally plug and play. So I've got the information on that on my GitHub. So if you go over to GitHub, look at my repositories. I know that always sounds somewhat naughty. You will see all the information on how to set that up, including a link to the SD card image. And I'll be updating that soon, because there's some new updates for the web interface that let you do pretty neat stuff like updating the firmware and things like that over the web interface. So that's that guy. I don't have a website for selling boards at the minute, but as I say, if you want to build your own, you can go over to GitHub, and the files are freely available there. What else is there? How many kilowatts can you get from the Tesla motor? I don't know yet, but we're going to be finding out. You can kind of speculate about that. I mean, one side of the coin is that because the because the open source control board is not limited by any of the Tesla firmwares, you know, theoretically, you know, you could push the motor to destruction. I'm going to try not to do that because I've only got one. But if you guys want to do that, then please do and video it. But we will be bringing the Panzer to a dyno once we get it, you know, reasonably completed, and once I get all the batteries in there and stuff like that. So there's yeah, there's that. You know, the other school of thought is that the Tesla firmware, you know, probably has a lot of clever tricks in there, and with me not having that, obviously, or having the knowledge behind that, that we may not get, you know, as much power out of the drive unit at all. So it's just going to be, you know, the only way to know this is going to be to test it and test it again, and if I screw up, go back and, you know, change something and test it again. The kind of boring part, a bit like this live stream. Is it possible to convert 2013 or newer BMWs? I think it might even be actually easier to convert newer cars because there's so much integration in there. So I think anything is possible in that sense. Could the Rex component be applied to a drive unit other than the i3? Yeah, I think so. The Rex uses its own inverter. Do I have it here? I did have it somewhere here. Oh yeah, hang on, it's back here. I did manage to take the cover off it. This is the Rex inverter. DC in here and AC out to the generator there, and this guy, basically what it has to do is it uses the generator to spin the engine to firing speed to get the thing started up, and you know, then obviously it turns into a kind of a rectifier power controller type thing to take the power from the permanent magnet alternator and feed it into the battery or the inverter or whatever you want to do with it. So yeah, I mean, you can you certainly can use that for other vehicles. It just needs to be worked out how to do that. So yeah, you know, this is kind of things I'm going to be working on, but at the minute I'm trying to get as much of the Tesla stuff done. Speaking of the Tesla stuff, we have a new patient on the operating table from Mr. Musk. Say hello to the Gen 2 DC to DC converter. Quite a nice piece of kit this, liquid cooled, and capable of quite some power, I think. Let me see, 9 to 16 volts DC, 2500 watts maximum. So that should be able to kick out a few amps. So we're going to be working out how to control this guy in some upcoming episodes. So stay tuned for that if you can stomach my content, which, you know, not a lot of people can, including myself sometimes. So yeah, we got to get that working. We got to, this horrific thing. This is horrific, guys. I mean, this is, I can't, you know, I can't really deal with this. Like, it's, you know, even if you'd said to me back in 2002 to design a, you know, a 3-phase motor controller, I mean, Christ. All right, okay. I'm not gonna rag on about it. Probably, you know, drive everyone crazy by now. But it is really bad. That's just really bad. I don't know how else to say that. What else are we doing? Oh yes, the i3 motor as well. We're going to be getting that spinning, so that's going to be fun. Not sure what control mechanism I'm going to be using for that. I might be going with the Hubner solution, or we might be going with the Lebowski brain. So yeah, that might be that could be a new variant for me. So we have to see how that works out, because that is a permanent mag motor, and it's got a resolver on there, and I have a resolver to digital converter circuit, so yeah. Just seeing as well, we've a Tesla current sensor that needs reverse engineering. Jesus. I have a lot of Tesla stuff. Oh, and we got to get a Tesla BMS controller working too. Ugh. I need to start a cloning, some kind of a cloning factory. That didn't quite work out too well for Arnold Schwarzenegger in the 6th day, so I might just have to leave that for now. Anyway. Oh, you've got one, Jeff. Okay. Well, then it looks like it'll be someone else working on that. So hang on, I got a question here. Is the firmware required through GitHub for your logic boards the same as the firmware commands the OEM Tesla? No. The OEM Tesla board is a very different, anyway, if I can find one here. I mean, this is a large drive unit logic board. There's 2 big TI DSP chips on there, and there's a what's the other one? It's a it's a bidet chip. It's a FPGA, and there's lots of components on there, and components on the other side of it, and lots of fancy Musk type firmware in there and all that kind of thing. Whereas my one has got a $5 STM32 on there, and some passives and a couple of cheap gates, and there's no components on that side of it, so that doesn't look very impressive. So very different software, but it is an AC induction motor, and I have controlled AC induction motors quite well with the Hubner system, so that is something that we need to test. As I say, and I am testing this. I've built a damn car, guys, with this thing in it. So yeah, I've got to go. I've got to start driving the car, and I have started driving the car, but I got to get batteries for the car. Then I've got to put the charger and the high voltage junction box and the Tesla charging port in the car, and then then I have to get this thing working. Hold on, it's on its side. It's not going to look too good. I'm going to belch as well, sorry. Okay, look at this guy. BMW, I think it's F11 gear shifter. Really cool. So we are going to be installing this in the Panzer, and we got the old, ooh, look at that, and the kind of and the click and all that, and fancy lights and stuff come on this thing. But of course, being BMW, there's a logic board thing in there, and there's we got to reverse engineer this. But don't worry, I am going to reverse engineer this, and we're going to use, yes, we will use a nano in there. So we're just going to glue that in there and wire it up, and then we'll simplify the hell out of this thing. So gear shifter, Christ, another project. All right, what else? What do we got going on? Yeah, the high voltage junction box has a lot of intelligence in it, but I'm treating it a bit like I treat myself, as a dumb box at the minute. Now, I can do that because in its default configuration, the high voltage junction box basically configures itself for AC charging. It's when you want to do DC charging that you need to use some of the fancy Muskian technology in there. So at the minute, I'm skipping over getting too deep. Oh, I've got a sore back. Into the high voltage junction box, so I can concentrate on some other stuff. We will be back, definitely. When we want to do DC fast charging, because we do want to do DC fast charging, and yeah, so that's definitely I'm going to have to reverse engineer that. Christ, is there anything I don't have to reverse engineer? Oh, sometimes it does get a bit overwhelming. Too old for this, Muttley. All right. Am I familiar with the Evora conversion? Yes, very much. I think it's fantastic. I actually came across that because I followed the Speed Academy channel on YouTube and came across their reviews of that. I think it was a fantastic project. I think, you know, I suppose like a lot of things, it's when I first got into EVs, coming up on 9 years ago now, which is scary, came across this kind of a saying that, you know, you wanted your car to be cheap, fast, and have a long range. Pick two. So I guess, you know, what the guys did there really was they kind of picked being fast and having a long range. So I mean, it's not cheap to do, certainly, but yeah, I think it worked out very well. But it's like everything else. There's more than one way to do it. So, you know, I'm doing it this way. You know, I don't know. Hopefully, it's going to work out. May not, but even to this date now, I've certainly learned a hell of a lot about motor control, inverters, circuit design, all that stuff, and I'm really enjoying doing this stuff. It may not seem like that sometimes, but yeah, I am. It can be frustrating, but when you get something to work and you've kind of got, got your head around it and you get it moving and all that, yeah, it's very, it can be very satisfying. So yeah, that is our. Oh, by the way, yeah. Speaking of Tesla logic boards, yeah. You know, here at, you know, Crazy Demos used Tesla logic boards, people think we are crazy when they hear the prices on our stock of used Tesla logic boards. So anyone needs a used Tesla logic board for drive units or chargers, you know, send me a message and you can, you know, sell you one of these pieces of crap. Because at the minute, for me, they're basically, I'm just, you know, I kind of used one this morning just for scraping the millimeter of snow off the car. So cars, plural. Jesus, more than one car. It's the problem having more than one car is, it's like, I don't know what it's like having more than one car, because I've always had more than one car in one sense. Solar panels are doing very well, thank you. I wish I could fit more of them, but I've just got to stay within the size constraints that I have at the minute. But yeah, solar panels are great, and believe it or not, they're just insanely cheap to get now. My pal Dave, that you may have seen in some of the videos there, he's fitting a solar system now, so I'm going to be giving him a hand with that. And you know, he's purchased some kit there that's just, you know, unbelievably cheap. So more solar, the better. Well, charger boards will be available soon. We've got a stock of them getting built at the minute, and I've got to get a test rig made up for them. Oh God, no, that's another project. Oh God. Why am I doing this? Why am I doing all this stuff? I don't know. Oh, okay. So someone has developed their own BMS for the Tesla battery slaves. Cool. Okay. So thank you for that. Be great to be great to see what you've got going on there. It'll be certainly one less project for me to do. So that would be very handy, because I'm not going to be able to use the original Tesla BMS even if I wanted to, because I'm only going to have 10 or 11 modules. So that would preclude the use of the Tesla BMS. But we can use the Tesla slave boards. EVTV and Colin Kidder did some great work on that, and I've done some experiments just very quickly on the bench here, just that I could communicate with them in the two modules that I have at the minute. I need to find more somehow. I don't know how I'm going to do that, but hey, that will be the subject for a new video. Okay, you can use 1 to 16 modules. Cool, perfect. Thank you, sir. I will be getting in touch with you. So yeah, that is where we're at. So I've got to get I've got to get steel as well for making battery trays. So that is something I need to remember to do this week also. I'm probably starting to rant a bit now. So if I start ranting, just just tell me I'm ranting and I'll go away. But anyway, yeah, this, yeah, no, cannot, bad. Don't like that, but still gonna have to use it in some fashion. Ugh. Right, so yeah, so we got Tesla stuff. Yeah, so we've got a few other Tesla components. We've got some other Tesla components going on. We have front junction box and air conditioning compressor and a few other kind of accessory bits like that. So yeah, we're going to be having a look at getting those running as well. That's also part of the plan. This BMW system, yeah, I've kind of got a bit of a dilemma going on at the minute. So well, yeah, that's true. I still have the bushy brows. All right, so mm, so am I aware if the hacked Tesla drive units from EVUS style boards is their own logic boards, or do they do a firmware for the Tesla logic board? I'm not actually sure. To the best of my knowledge, they use the original Tesla boards in there, and they either flash a particular firmware into them so that they can use CAN control. That's the best of my knowledge, but don't really know too much about those particular systems. I do know when I got the Tesla drive unit, I did spend about a week kind of researching and kind of looking at how I was going to run it, and kind of looking at could I use the CAN method and things like that. So yeah, I just decided I was going to plow a different track and just go with the logic board because nobody had actually done that. So yeah, each method has its own advantages and disadvantages. So we'll see how this works out. So as I said, it's been a bit of a blast either way. I better not use the word blast. Do I know if the EU and US charging junction boxes differ? They certainly do. Because in America you have two-phase power. So whereas in Europe you would have three-phase power for the on-street charging point. So the US high voltage junction boxes have got two contactors for switching the charging port, and the EU one has got four because you've got neutral and three-phase. So there is a difference in there. Now you can use a US charging port in the EU, but you would be limited to single phase. You could use a US high voltage junction box in the EU, but you would be limited to single phase charging. Now that may or may not be a big deal because you may have seen in a recent video I was able to push a 10 kilowatt charger to full power on a single phase feed, albeit it was pulling around 45 to 46 amps on the AC side at that stage. Oh, excuse me, belching again. Oof. I tried to drink water this time, not fizzy drink, so I wouldn't belch, and yet here I am belching. Jesus. Anyway, more water. So yeah, that's kind of about where I'm at the minute. There's an awful lot of stuff going on. Hope you guys are enjoying it. I know we haven't had too many videos recently, and just dealing with some health issues. So I have issues. So I'll get through those eventually, and yeah, we'll keep on trucking basically. So I don't think there's anything else that we need to go on. Only I'm just going to have one more rant about this thing. It's just, it's just unbelievable that, I mean, I couldn't have conceived of that. And I think only for I just went, just into it with a kind of a, blank head today, and just found out how the thing really worked. It just freaked me out. So, freakazoid. I'm going to call this the freakazoid inverter, because it's really freaky. Alrighty. Yeah. So welcome to the most boring live stream ever. It's only the second one that I've done, and I've managed for it to be more boring than the first one. So that probably means I've won something. My pleasure, Jeff. Keep on ploughing at some point anyway. I might hit a few rocks on the way and kind of, have a bit of a problem, but yeah, we'll keep it up. We'll keep it up. All right. Here's a question. I'm going to throw one back to you guys. I was seriously thinking about in terms of the BMW stuff. Okay. See, I have an E39 Touring, and the engine in that I have nicknamed it Backfiring Betsy, because it basically likes backfiring, particularly when it's cold now. So I'm waiting for the day when one of those backfires eventually blows the plastic intake manifold and the throttle body and all that stuff off. And at that point, then I will have another project car, because I really need another goddamn project car, don't I? All right. So then, what I was thinking about doing was using the i3 motor. Okay. Great. Using the i3 motor and the i3 inverter and the Rex, and make myself some kind of crazy hybrid. So yeah, that might happen. So I don't know what you guys think about that. Maybe that's nuts, but I'm figuring there's no real point in me going to get another engine, because this isn't an engine channel anyway, but I could still, fit it. But then I'm getting another clapped out engine that will then become Backfiring Betsy the second. And, then I'll be right back to where I started. The switching of IGBTs and waveform to produce takes a lot of software development. Yes, it does, I suppose would be the short answer. Keeping in mind that I don't write the software for, these boards. The software, even this one here, this is one of my versions of it, but the software was developed by a German gentleman by the name of Johannes Hubner. And he came up with in my view, a amazingly simplified way of controlling an induction motor. And I put this in the E31 the first time, and with the Siemens motor, and that car moved. That was a 80 kilowatt motor, and I pushed 120 130 kilowatts into it. So he's here. Okay, hello. So I have little doubts that the software took a lot of time to put together, but I think it's at a point now that it can pretty much drive any AC induction motor. So we'll and the Tesla induction motor is probably the most advanced AC induction motor for a passenger vehicle that we're going to get. Now, when I get a Tesla truck, and you know, then we'll have a different conversation. So yeah, we'll be doing this. To the best of my knowledge, the Model 3 uses well, I have heard, I don't know, but I think the Model 3 uses some kind of permanent magnet motor. So we will be, you know, that is something that Johannes and I played with a few years ago with a Lexus hybrid gearbox. So we did get it to run. So we might end up looking at that again for the i3 motor. And possibly, if you know, there's no if, is there? It's when I get a Model 3 drive unit. I see one of them took off recently. It flew over a river and kind of did a General Lee on it and just, you know, went down onto the far side. So maybe someone can get me the drive unit out of that thing, and I'll soon tell you then if we can drive a permanent mag motor. Build a E30 M3 hybrid. Well, my pal Dave would be a big fan of that because he's an E30 maniac. So I'm actually, I wouldn't be surprised if my next project ends up being an E30. So might actually get there. Yeah. So more cars, more BMWs. The problem with BMW is they keep coming out with new models faster than I can convert them. So, you know, obviously I'm going to run out of quarters and BMW will still be there and I'll be dead. But, you know, hey. BMW were here before me and BMW will be here after me. So, you know, I guess I just have to live with that. AC induction motor can't do regen. I can assure you it can. How do I know that? Is because I had the regen turned up real high in the Panzer, and I was going to do a Rockford because I'd been watching too much Roadkill, so I decided I was going to do a Rockford, and I went shooting backwards in reverse. Touched the brake pedal and the motor said, oh, I want to do regen. I want 50 kilowatts of regen. And the car said, yeah, we can do that. The drive shaft said, yeah, we can do that. But the gearbox said, no. And the bits of the gearbox came out through the side of it. And then there was no more regen. So, yeah. And then my $50 a gallon oil ended up on the road, and I had to push the car home and spend the rest of the day crawling around, getting a new gearbox, putting the thing in, and oh Jesus, yeah. No, I can assure you AC induction motors can do regen. Do you still refer to permanent mag motors as induction motors then? Well, no, I don't think so, because an induction motor gets its name from the fact that you're inducing the rotor field from the stator field, whereas a permanent magnet motor has its own rotor field from the permanent magnets. So, well, I'm glad you guys find this interesting. I must be driving someone mad. What else we got? Any thoughts on detecting the synchronous reluctance in oh my god, that's a mouthful. Hang on, wait till I try this. Synchronous reluctance internal permanent magnet motors in the net gain Hyper 9. My god. I don't I've no idea. I guess anything's possible. I'm not a motor aficionado. I mean, I've been 9 years at this, but I spent the first, nearly 5 years with DC motors. It was only when I got the Siemens motor that I got my first AC motor, and I've been on a steep learning curve and driving Johannes crazy, asking him stupid questions for about the first year, and then I just asked him more advanced stupid questions for the second year, and now I just annoy him generally, I think, for subsequent years, and start coming up with things like this. So yeah, okay. Can this inverter software run at 10 kilohertz? I'm sure it can. The switching frequency at the minute I'm running in the Tesla motor is 8.8 kilohertz. And there's oh, there you go. Okay, that's solved that problem for me. But I've been running 8.8 kilohertz. One of the things I noticed when I was bench testing the Tesla inverter was it would run at 17.6 kilohertz, but the DC current draw from the drivers increased a lot. I forget what the figures were. It might even be in one of the videos when I was, when I had it all set up here. The DC current draw, like, I don't know, just for the sake of argument, might have been, 500 milliamps, and I was running at 8.8 kilohertz. But when I wound it up to 17.6 kilohertz, it went up to like 1.5 or even 2 amps. It went up like 2 or 3 fold. So I kind of, you are using more energy because you're switching, you're switching more frequently, hence the, increased frequency. Oh, cracked the back. Anyone know any good cures for lumbago? That's one of my big problems. I need a decent chair too, so it's one of those things, isn't it? Probably don't really help myself out. Do permanent magnet motors use less energy since they do not have to generate all the magnetic fields? Don't know. Possibly. My sense of it though would be that motors are a lot like everything in life, really. You kind of win some and then you're going to lose some. So yeah, is it going to make much difference? Like most of the OEMs, like the BMW, the Nissan Leaf, most of those guys are using permanent magnet motors, and of course that gets all the conspiracy nuts going crazy. Oh my God, electric vehicles are really bad for the environment. You're mining up all these crazy magnet materials. It's going to blow up the planet and then we'll have to live on Mars, and that's going to be dreadful because I can't drive my pushrod V8 on Mars. But hey, yeah, I wouldn't worry about it too much. The odds on us, I think it's the same with batteries too. You get, mining all the lithium is going to blow up the planet and then I have to live on Mars. Well, yeah, no, it's actually, if you look at the weight for weight, the amount of lithium that's in a battery is, not much at all. It's more copper and aluminium, and then it's, oh my God, we're mining copper and aluminium. Yeah, we surely are. We've been doing that for a long time. Anyway, try not to rant too much. We've probably already exceeded the ranting radar. So anyhow, yeah, bad and over bad. BMW good. Well, BMW semi good. BMW kind of weird because they've got a load of chips and stuff in there that I've no idea what they do. So maybe they're for controlling the built-in blender or something. I don't know. Does the Tesla 10 kilowatt charger have active power factor correction on the 240 volt input? I sure as hell hope it does, considering the amount of juice I managed to suck out of the house last week. But short answer is yes, it does. Because each of the modules actually reports a booster voltage, which is, I guess, is a booster PFC stage. And there's lots of weird voltages. Those Tesla charger modules kick out a lot of CAN messages. It's kind of CAN city. The good news, though, from a CAN perspective, is I think controlling the DC to DC converter is going to be a lot easier CAN message wise than I had thought. So I've been doing a little bit of research today on that while this thing, in between this thing annoying me. Oh, okay. I've had the Pi crash on me when I've been messing with it, but I haven't crashed on me when I've been, you know, just using it for the access point. But, you know, I wouldn't be surprised. These things are not, you know, they're not exactly bulletproof. But that being said, I would be a lot happier with using this for my wireless access point than trying to install, you know, than trying to talk someone through. Because, like, you take someone that just wants to get a motor running in a car, and, you know, okay, like, they're kind of happy enough doing a bit of soldering and maybe, you know, wiring stuff up and, you know, setting up voltages and all that kind of thing. But I mean, you then say to that person, okay, right, so now we need you to install a lamp server on a Linux laptop. And it's kind of, whoa, what do I do? I need a flashlight, do I? And it's kind of like, oh God. So not doing that. Pi, and I know Johannes is working on an ESP 8266 version that's also even, you know, probably simpler than the Pi, but I'm going to stick with the Pi now because I'm kind of like that. Once I get my mind on something, I tend to stick with it. Some kind of weird, misguided brand loyalty type thing. So that's why, yeah, that's why BMWs now for the last, I don't know how long. Oh, wait a minute. 9 years? Yeah, 9 years, 2009. Jesus. So, yeah, that's kind of where we're at. So I have gone from having no OEM bits to all this OEM stuff everywhere that I'm buried in it. So, trying to suppress the belches. Do iOS scope check and charger or anything? Test the power factor. Yeah, I can actually. I do have a power factor meter, so I can. I can certainly do that. We'll see if we can get a figure for it. I don't can't remember it off the top of my head, but hey. It was displayed on the meter, but I was too scared when I was running it at 10 kilowatts to, you know, reach across and things like that. So, so is the software any different between what runs the Siemens motor and the Tesla motor? Pretty much no. It's pretty much the same core. Like, all we really did for the Tesla variant is just reading the current sensors and things like that. So yeah, I've never used the ESP8266, so I'm gonna have to blood myself on that as well. But, you know, like I say, sometimes with all the stuff going on, it can pretty much get overwhelming sometimes. So you just, you know, you say, and not another platform that I have to learn. No, I can't do this. I can't learn another platform. That's kind of why I stick with Design Spark for the PCBs, because I am not at my age now going to go and learning another PCB package. I'm too old for learning PCB packages. So it's Design Spark, and yes, Design Spark is Windows, and yes, that's annoying, and I have to keep Windows on the computer for that, but hey. Alrighty. I know the last time I did a live stream, a lot of people said I should keep it at less than 1 hour. We've now exceeded 1 hour, but hey, you know, this is me, and I have zero problem in boring people to death and, you know, causing people to unsubscribe and all that kind of thing. So I'll just keep going until I can't anymore. But anyway, don't know, guys. I think that's probably about it. Like, I've as I said, I'd probably do a video on the pre-charging stuff. I didn't get a chance to do that yet, but at least I give a little description in this, anyone that's had a question about that. So yeah, we've got a lot of exciting stuff going on. I kind of, you know, part of me almost kind of wishes at some point that there'd be some kind of a, you know, a business in this in some way, but either ways, it's you know, I'm doing something I love, so there you go. All right, I better wrap it up at this stage because I'm just killing people, causing suicides. So right, we will see you guys next time. This was a little bit impromptu. I didn't really plan to do it. So thanks to everyone that's tuned in. And yeah, we will. I'll try and plan the next live stream a bit better, and actually have something more to talk about than just moaning about the ANOVA crappy design. And we'll have yeah, we've got a lot of development to do. And one last thing, I suppose, is that I really part of this that I really like is making the information available. And that's the whole reason I go for the whole open source route for this stuff. And that'll always be the case with me. You know, I'll happily sell you a board, but if you can't afford it or you don't want to buy it from me, the design will be there and you can go make one for yourself. This is what got me into EVs in the first place, was being able to make Paul Holmes' DC motor controller. So I want to try to pay this back to people, and you know, I wish more people would do this stuff and, you know, make it all open source and we could all share it and not end up going back over the same stuff. But hey, that's life. All right, guys, I'm glad you all got something out of it, and we will see you next time. I'll probably have a video of the car fairly soon coming up, and we will. Yeah, I've got to do updates on that. We fit in the charger and stuff, as I said to that. So my pleasure. Glad I was able to. Glad, as I said, you know, I get a real kick out of making the stuff available, because I think, you know, I just think that's the way to go. I think it's the way all this stuff should be. We've got to push hard for electrification of passenger vehicles, and I think the conversion side of it and all that has a very important part to play. I think the more that we can encourage that, the better. So that's the one, guys. I'm going to stop talking now. I'm going to just stop. So right, see you next time, folks. Don't forget to like, subscribe and share, and I'll put some links in the description of this for the GitHub and that, so if you guys want to download stuff and go off making boards, by all means do so. And yeah, that's about it. So take care, folks, and see you in the next crazy live stream.